All right, back with section 1.3, where we are investigating linear functions. Okay, so linear functions, rate of change, constant functions, and this relates to revenue problems, mostly business-related questions. So money in, money out, that kind of thing. So that's what we're talking about. The general form of a line that you might remember is y equals mx plus b. Right here they call it ax plus b, but it's really the same thing. F of x is equal to y. So x is our input value, and f of x is our output value, y. And a is constant. That means, let's say for every computer you sell, it costs $500. Okay, so 500 times x, and then plus, let's say, your upfront costs for your machine or your building or whatever you're paying a one-time fee. So that's just applying it. So I want you to determine whether these are linear or not. Well, you have your grapher, but you should have a general idea mathematically and with your number sense. Whether that works or not. I just forgot to relabel my new sheets. Every time you do a new section, you want to relabel a new sheet. This is 1.31. I don't want to get that put on there with 1.2. So in any case, they asked you whether these are linear or not. Well, you can put them into your grapher and see if they are linear. So y equals 9 is going to be linear. It's going to be a horizontal line. X, y equals 5 is not, because you have to solve for y. And you're going to get y equals 5 over x, and x cannot be 0. So that's why there's no graph when x equals 0 here. That's called a hyperbola. That means you have a break in your graph. That means there's a problem, and there's certain values that cannot work. And the last one there, you just basically interchange x and y for t and s. So that's what I did, made x, t, and y. Remember, you have to change this x and y for decimals to work, and that purple line will work as well. So that is linear, okay? So let's turn these guys off so we don't get distracted. So we're talking about linear functions, particularly in this section, and as it relates to business. Okay. Moving on. Determine whether this is functional linear function. We did that already. Okay. Oh, also give the domain and range. Okay. So domain and range. So the domain of this one here demands any value for x. So negative infinity to infinity. So x could be anything negative infinity to infinity here, right? Range is only one y value, just 9. So the range is just 9. Okay. So remember, what's domain and range? Possible input and possible output values. Well, here for domain and range, it's not linear. The domain is negative infinity up to 0, and then 0 to positive infinity. You always look left to right for domain. A range, you're looking vertically. Now range is going to be negative infinity down here up to 0, and then 0 to infinity. So you do not include 0 in both cases. You write that out with a parenthesis, soft parenthesis. Okay. Likewise for the last one. For this regular linear function, it's not horizontal. So for a linear function that's not linear or not horizontal, diagonal, the domain is not limited at all. So negative infinity to infinity, it's not restricted. Range, you're looking vertically here, not limited at all. So you say negative infinity to infinity. All right, but in the context of a business problem, sometimes we're going to start with 0 because 0 products, or you can't have less than 0 products or made, or 0 employees. So that's why sometimes we restrict the domain on our own, because it doesn't relate to real life. Okay. Intercepts. So intercepts mean where one variable is 0 and the other value crosses an axis. So for instance here, x equals 0, but so the y-intercept is 5, okay? So x is 0, y-intercept is 0, comma 5, the point here. Now here, whatever intercept you're looking for, the other variable is 0. So if you're looking for the x-intercept, then y is 0. So you put a 0 in for y right here, and you solve for x, and you get a decimal answer of negative 1.67, but that's how it works. Okay, so intercept means what point does the graph cross that axis? One of the variables is going to be 0, and one of them's not. Okay. Moving on. Find the x-intercept and y-intercept. Well, so yeah, so you plug in. No, I don't plug in. You evaluate at one variable equals 0, and then you solve for the other variable. So you put in, you evaluate 0, you substitute 0 here, and you get negative 2. And so an intercept is a point with two coordinates, 0, comma, negative 2. Now an x-intercept, y is going to be 0. So when y is, put the 0 there, when y is equal to 0, you get 4. So it's 4 comma 0. So intercept is more than one number. Okay, it's a point with two coordinates. All right, so here's a business problem. All right, now I get into a business problem here. All right, so business property is purchased with a promise to pay off. So they're promising to pay off a $60,000 loan, plus they had to pay $16,500 in interest, and they have to make 60 monthly payments. This is real life right here of $1,275. The amount of money. So it's very important to read the problem. The amount of money Y remaining. So Y stands for the remaining balance. Okay, to be paid off is $76,500. That's what they owe all together, the loan, and they're paying it off in $1,275 payments for each payment. Now, so Y is going to be going down, right? So as the payments increase, number of payments that are paid off increase, the balance goes down. That's what this equation means, all right? So we say Y equals 76.5 minus 1275 per payment, and X stands for the number of payments. So very important to identify the variables. X stands for the number of payments made. 1275 is how much each payment is. 76.5 is how much is owed, and Y is the remaining balance. Okay, so you can't see that yet because it's not zoomed in right. So now we have to set the wrench, right? So X is the number of payments made. So since there's 60 payments, we're going to set X number from 0 to 60. Okay. Because that's where payments are being made there. Okay. Now Y's got to be, Y stands for the amount left, right? So the balance left. So the balance can't go any higher than 76.5, but it could go up to there. It's really annoying when you click there and it goes away. That's what's happening here. So that goes 76,500. Sometimes you could you can do this by using the number 76.5 and just call it thousands, you know what I'm saying? But let's see how this looks. If this gets hard to read, no, we can do it. Okay. Sometimes like we can do like a key and say, okay, 76 cents or 76,000. But I think we work this one out. So there's our nice graph. So now we can answer questions about it. Find the x-intercept and y-intercept. Well, x-intercept's down here, okay? So you can just say x equals 0, oops, and then y equals 0. So we know what's going to happen yeah, so this is the x-intercept, 60, 0, and the y-intercept's up here, 0, 76.5. Okay, so we got that. Moving on. Keep saving. So that means at time 0, well, if you make at times after 60 payments, your balance is 0, and this means that after 0 payments, your balance is still 76,500. That's what that means. That's called interpreting a point on the graph. And the reason why, obviously, 60 payments, that's why we stop there. 76.5, that's why we stop there. That's what this is saying. That's our graph. Ours looks nicer. Now we're talking about slope, which is a rate of change, okay? So it's talking about a rate of change. They say rise and run, I do not. So we're going to say vertical change over horizontal change. It's like a staircase, okay, like steps. So it's vertical change over horizontal change. That's the way you want to remember it, okay? So find the slope of the point passing through here. So we're not going to do, when we do these problems, they're going to be in context of a word problem, so they're not going to use a straightforward problem like this without being connected to something in real life. But you would do what's the difference between 3 and -1? 4, right? So just say, okay, the difference between 3 and -1 is 4. Put that here. What's the difference between -7 and 5? It goes up 12. So this one goes down 4. 3 to -1 goes down 4, negative. It's -7 to 5. That's a difference of up 12. So it's -4 divided by 12 is -1/3. So it's just getting you ready for an application question, but it's vertical, which is y. Remember, x, y, they are alphabetical. So it's difference in y's over the difference in x's, vertical over horizontal. All right, the basic shapes of slope. Positive slope, as both variables increase together or both variables decrease together. Okay. Negative, meaning as one variable increases, the other decreases. Zero slope. So zero slope and no slope are not the same thing. Slope of zero means as one variable changes, the other one stays the same. Okay, so it's constant. You call that constant. So one variable stays the same. All right, the other one changes. And this one is, the slope is not defined because we're kind of dividing by zero. So that's a problem. It's undefined. I mean, it doesn't exist. Cannot be calculated. All right. The slope of the graph. So you think about slope-intercept form. B is the slope. M is the slope. B is the y-intercept. Sorry about that. So determine the slope. Well, the slope is going to be, we can plug that in here. So we have something like y equals 7x minus 12. We put the home button, so those numbers relate to what we're doing. Hit the home always brings us back, so we don't have to zoom again. So slope's going to be 7. It's the number before the x. Now in this case, we don't have a slope, right? It says 2x minus 3y equals 12. 112, 12. Now in that case, it doesn't say y equals, so you're going to want to solve this for y. Subtract 2x from both sides and then divide by 3. So you subtract 2x from both sides, it's going to be negative 2x, and divide by negative 3, it's going to be 2/3. But let's say we didn't know that. Okay, you can just find any 2 points, like there and there, and then you can find the slope. So what's the change in y? It goes up 4. Positive 4 is my numerator, and this is going to be a up 6, positive 6. So it's 4 divided by 6, and that equals 2/3. Okay, that's why it's 2/3 for the slope. There you go. So if you put in y equals mx plus b form, you'll see it's 2/3 there also, but you can do it with the graph. All right, so last problem here we'll do is a real life problem. Application. So back to the old problem. Okay, so back to the old problem that we had with the interest payments. What do they want to know? What are the slope and y-intercept? Well, the slope is going to be negative 1275. So that means every payment, the balance goes down $1,275. So that's what that means. So the slope is right here. It's already in slope-intercept form. Y equals mx plus b. B is going to be your 76.5. That's going to be at times 0. You owe $76,500. That's what that means. So we don't have to go back and redo that one. We can see it right there. So slope is the rate of change. That means it's telling us how much something is changing over 1 unit of time. So one payment, every payment, your balance goes down $1,275. That's what that means. Okay. So you can make a table like that. You can graph it out. We did this already. Right there. But we have to zoom it out. Oh, we don't have to go crazy looking for it. We did it again. Just set the wrench back and you can find out what that is. We did this graph already. And then table of values. Well, you can just put x equals 1, x equals 2, x equals 3, x equals 4 in your calculator, and you can get these values. Or you can make a table. Okay, so you can do that too. So you're going in here and you say, okay, and again, don't forget to make your table. You say, all right, x is, so at time 1, it's going to be 75, 225, and then you keep on going. And then 2, 73, 950. Okay, now you might say, well, how do we get that graph back? Don't forget, you go back to the wrench, okay, and you set that graph to, what was it, 0 to 60? And then y was 76.5, I think it was. And this one was 0, I think. So we can go back and we can see that. All right. So rate of change y equals mx plus b. The m is the rate of change. The m is the slope. So in this case right here, the slope here is 0.224. So that means this is talking about the number of Hispanics in the U.S. population, percent of Hispanics. So every year, the percent of Hispanics population goes up by 0.224. I better stop it there.